metallic solids, and covalent network solids. In addition to ionic and covalent bonding, there are two other categories of bonding that give rise to solid materials with distinctive properties: metallic bonding and covalent network bonding. Metallic solids have many useful properties, including the ability to conduct electricity and heat and to be formed into shapes such as sheets or wires. In pure copper, the copper atoms are closely packed together and their valence electrons are delocalized. This results in positive metal cations that are surrounded by the freely moving valence electrons. The attraction of the positive metal ions to the free valence electrons is metallic bonding. When a copper wire is connected between two ends of a battery, free electrons move through the wire toward the positive end, producing an electric current. This property is why metals are electrical conductors. In covalent network solids, atoms are held together by a network of covalent bonds. Graphite is a covalent network solid consisting of flat sheets of carbon atoms arranged in a hexagonal pattern of alternating single and double bonds. Electrons rearrange within sheets, but not between sheets. Although graphite can conduct electricity, since the electrons in graphite move less freely than the electrons in a metal in response to electrical forces, graphite is classified as a semiconductor. The forces between layers are much weaker than covalent bonds. This allows the layers to easily slide past each other, and is why graphite is a relatively soft material. Another form of a covalent network solid made of carbon is diamond. In diamond, each carbon atom forms 4 single bonds in an interlocked three-dimensional arrangement. The electrons are localized to the bonds between pairs of atoms, and so are unable to move when an electrical force is applied. This makes diamond a non-conductor and one of the hardest substances on Earth. Copper, graphite, and diamond all consist of large three-dimensional arrays of atoms. The different ways in which electrons are distributed in metallic bonding and covalent network bonding explains the different physical properties and uses of these materials. Key takeaways. To summarize, in metallic bonding, valence shell electrons move freely, so metals are good conductors and malleable. In covalent network bonding, valence electrons are shared between pairs of atoms, which are part of a large, extended structure.